So we just saw all of this explained in a real-life context. As we go back into the math portion, we'll see that whenever the graph of f of x interacts with the x-axis, f of x equals 0, a value of x for which f of x equals 0 is considered a function, a 0 of the function, sometimes considered a solution to the function. As we see from this example, we have two of them. To find the zeros of a quadratic function, solve the related quadratic equation where we pretty much have the trinomial, or what we're trying to factor, just set equal to 0. This is the reason that factoring kind of works, is because all the terms are on one side. We can then rewrite that accordingly. You can solve some quadratic equations in standard form by factoring, which is, again, using diamond method, getting your product at the bottom, sum at the top, factors here, and using the zero product property rule, which is saying that if we have two factors and it's collectively equal to 0, the product of the two factors equals 0, that implies that the first factor can equal 0 or the second factor can equal 0. So the key thing here, and this is a really big important part, is that all terms need to be on the same side of the equation before factoring. And imagine how this would look. If you were trying to factor something and you had x squared plus 2x equals 5 over here. You could use eventually completing the square, but there's not too much we can do at that point in time. So with this section, we'll just rely on factoring and see how it goes from there. So we have all of our terms on the left side of the equation here, x squared plus 3x minus 18. If we factor that, we have negative 18, positive 3, getting a product of negative 3 and positive 6. So x plus 3, scratch that. We can rewrite this to x minus 3, x plus 6 equals 0. Using the zero product property, this is saying that either x minus 3 can be equal to 0 or x plus 6 can be equal to 0. If we solve for x on both sides, x equals 3 or x equals negative 6. So these are considered our two solutions. I'll give you a moment to try the next one out. Well, we know that we need to move that 12 over so that all of the terms are on the same side. We have x squared minus 7x plus 12 equals 0. We'll make a nice little note here. All terms are on the same side. So we're good to go. We factor this. We're looking for factors of 12. Sum of negative 7, negative 3, and negative 4 work just fine here. So we can rewrite this to x minus 3, x minus 4. When you're really quick with this, you don't even need to set up the steps seen here. You can just go with the opposite of what you see. So here was negative 3 we saw, but we really wanted positive 3. Here we see negative 3, but we really want positive 3. We see negative 4, but we really want positive 4. So our two answers seen there, 3 and 4. If we take a look at how we can do this on a calculator, of course, moving all of our terms to the same side with 10x squared plus 2x minus 46 equals x minus 4. So subtracting x gets us x. Adding 4 gets us negative 42. We can see here that we only have so much to work with. And we'll see how we can actually take a look at where this is all going to be and how we know that these are solutions. So If we take a look at our calculator, let's graph this out. First clearing everything. So we have 10, we've got x. Let's square it. Let's then continue with this with adding on x. As you can see on the computer, this is sometimes tricky, but 10x, let's square it. I'll get this right one day, I promise. So we got 10, we've got x, we're squaring that. We're then adding on x. We are then deducting 42. And we're hitting graph. So as we see here, we only have a little bit to work with. We could try to zoom in, which might help. So we can always zoom in to get a better picture of exactly what's going on. We see closely that we have two solutions here. We'll see if we can get closer to them. So if we try to zoom in even more, we're getting a little bit closer now. If we hit trace, we can then try to trace along and see how we can get that outcome of 0. So we see that it's a really close approximation. What's also cool is that if we hit second trace, we can calculate the zeros. So if we hit second and then trace, as seen down here, if we hit 0, we can just keep hitting x, I'm pretty sure. Usually that works. Let's see. So if we hit second, sorry, not alpha, second, trace, 0. We hit there, and now we're kind of going in between. We see that one of the x's is negative 2.1. We could also see where the other solution is. If we hit the same thing, second, trace, go to 0. Now as we start to move around to the other side, getting closer and closer, we know it's in between here and here as we see x's 2. So the calculator is really helpful for problems like this, and we'll see that in the next example that I'll give you some time to try on your own. Some examples seen here. So you're being asked to find the solutions of what's going on with this. Try it on your calculator, see if you can do that. So we know that we're being asked to go and solve when we have 4x squared. We're subtracting 13x. We're adding on 3. After entering the equation into the calculator, use the results below to complete the table. So making sure that our table set is from 0 to 10, but now 0 to 1. If we hit second and then table, we see that when x is 0, the outcome's 3. When x is 1, the outcome's negative 6, negative 7, 0, and also 15. We can also switch up the increment that we go in. So although this was going in increments of 1, if we switch this by hitting second and then table set, switching this to 0.5, then you hit second table. If we go by increments of 0.5, or sorry, 0.05. It's Sunday. I'm a little off on this one, so let's double check this. All right, now we're talking. It's 0.1, 1.74. We have 0.15, 1.14, 0.2, 0.56, 0.25 is 0, so we see a solution there, and also negative 0.54. So we see that we definitely have one solution just based off of that. We see another solution up here because that outcome is 0. So as we see here, we can use graphing on calculators to do this. We can also factor. We have a few options that we're now learning on how we can see solutions to quadratics.